name is Sherry List, and I'm co-founder and CEO of a startup called Synthetic AI Data. So, judging by the name, we are actually a synthetic data provider for training computer vision model. So we know the pain, and then we decided to come up with some cure for that. We are based in Copenhagen, Denmark, and we have a platform, we have an engine that we are working on it for about 3 years. And our startup is kind of backed by Microsoft for Startups, NVIDIA Inception program, and also we got a grant from Innovation Fund Denmark, which is like a governmental grant from our country. So we also, last year, we won a Microsoft Partner Award in the category of startups because of our innovative way to solve this problem. So, about our solution, as I mentioned that we have a platform, we have an engine that with our engine, our customers they can create the scene that they want in our platform, and then they can easily, without any hassle, generate the annotated data. So we chose the approach to make sure that our platform is a no-code solution, so anyone can actually use that to generate the data. Because we believe that in future, actually not even in future, but currently all of our teams, they are fusion teams. So it consists of people with a technical background, with a developer background, and also business background. So we should make sure that everyone is able and empowered to actually to generate this data. And of course, we all agreed that AI needs a lot of data. And currently, the way that people, and all of us, we are generating the data for training AI is that we need to spend so much of a time to collecting the data. Once we collect the data, we need to annotating. And then that annotation and collection is time consuming, and it's most of the time it's a very manual process. And we all know that as human, we make mistake. And in this case, this mistake costs us the accuracy of our model. And that's why that we believe that the solution for that is synthetic data. So synthetic data is the data that is generated by simulation, by computer algorithm. They are very much like real-world data, but they are, in reality, they've been synthesized. And the good thing about it is that since it is generated by computer, it's out of the box come with all the annotation data. So you can have the segmentation, you can have all the point for the object detections and so on without doing any extra work. And also, as you can see that, for example, in this picture, since this scene is generated by, that is a synthetic scene, so you can have even more than one object in each picture. So you can fine-tune it because this is what you that you have all the control over it. So you can have all of this annotation out of the box. And one thing is that we are not the one that we say that, hey, synthetic data is the future. So Gartner is also say that by the 2030, almost all the data that is being fueled for AI model actually all of this data that we use for training the model is fueled by synthetic data. And so in reality, you cannot have accurate data and a well-performed data without using synthetic data. And in our company, we have our focus is on mostly defect detection, because we know that that's an area that most of the, actually that the industry is lacking the data. It's so, just imagine that, for example, if you want to make sure that you want to train a model for finding the defect in this clicker, how much of a different types of defect this clicker could have. And then how much of a time you need to spend in order to create this defect, and take a picture, and then annotate the picture to be able to have a well-performed model. And that is why that we chose to actually to have this as the focus of our company. And I'm going to hand it over to Goran to actually to show us some of the recent projects that we did.
Hello, my name is Goran, and I'm co-founder and CTO of Synthetic AI Data. And recently, we became a strategic partner of Edge AI Foundation. That's why we are here today. And together with their data working group, we discussed some use cases, like what problem in industry we could tackle. And we decided to go after this problem of metal and aluminum cans. We all know how they look like. They are for beverages and food. And they are used nowadays in industry a lot because they are easily transportable, they are durable, and highly recyclable, like 90 to 95% of these cans is recycled. The thing with the cans that you maybe don't know, it's a huge industry. There is 627 billion units produced each year, and that approximates into 1.72 billion cans per day being produced out there. So it's pretty huge industry, and just in US, in 2020, it was produced 120 billion of cans. In Europe, there is something around 100, China is 75, and so on. So huge global industry, and projections are also that this will grow from 120 to 173 by 2030. This industry is steadily growing over the years. Challenges with metal and aluminum cans in the production is that those cans could have the broken tabs, could have missing tabs and lifted tabs, and this is basic functionality that we actually need to be able to open the can, right? So we want to be able to detect, is this can correct or it's not? For this purpose, we decided to develop a data set, and I will show you through slides some of the pictures from this data set. Here what you can see is standard beverage can. Imagine cola or beer. Those are the cans. But if you look a bit closer, like those cans are a bit different, depends on the top cover, right? And they also have the different opener tab on top for all of them. They come, this is, as I said, standard one for the drinks. Then there is a sleek version, which is used for energy drinks mostly. You've probably also seen those a lot. Then there are slim versions, then there are stubby versions. All those cans come in many different materials, and tubs come in many different colors. So here, showing you some of the variations. And what you are looking over here are synthetic images generated by simulation on our platform. This was for standard, then also some preview of variations for the sleek version of cans, slim, stubby, a lot of those variations. In this data set, as we were saying, we are focusing a lot on the defect detection and simulating actually the defects. And here you can see one example of a defect, like this is correct picture, and on the right there is a defect, right? This stub is bent. This could happen in production, and this is something that we want to detect. It might sound easy if you haven't worked with computer vision, like how to test the defects and such, but I can give you one example of one enterprise company that had a model in production not for this purpose, but for their product being able to detect the defects. And the way they trained their model, they took a lot of their products. Their data scientists took screwdrivers, damaged those products, took pictures, and then trained the model, right? We don't want data scientists to run around with screwdrivers, and we don't want them to break down our products. That's not sustainable, so it's much better to run simulations and create the defects. Few more examples of defects. Also, example of a bent tub, another variation of a bent tub. Few more previews here from the different versions. This is a preview of a broken tubs that can also happen. So in the dataset there is simulation of the broken and bent tubs. As you can probably see, I hope that you can, like, tub is half broken over here. In the dataset there are beverages, there are food cans also. Food cans come in many different shapes. They also come with different tabs on top. They come with in different materials. Tabs can be in different materials and so on. During the generation of dataset, I was showing you now just top view and one orientation of the can. During the generation, we generated images from many different angles, rotating those cans. And maybe pictures are too small over here to be visible, but you'll have access to that dataset. Feel free to check it out. There are different lightnings and shadings on those images, so light reflects differently on those pictures from the can, since we have the metal surface, and also the shadows are falling differently. In production, we could inspect the cans in two ways, with camera from the top looking down 90 degrees, right? But we could also inspect it on the side, because from the side it's easier to catch some defects, such as can being bent. So all those synthetic images are generated with also in a different view with camera angle, and here you can see that those tubs are bent. Maybe this one would be easy to detect from top, but this one probably wouldn't, because it's not bent so much. Where we ended up is generating the world's largest can synthetic images dataset, resulting in 3 million images, 2.985600 images, 267 gigabytes. This dataset will soon be available at the Edge AI Foundation AI Labs, so you can go over there and download the dataset and inspect it. We look forward to see what people will build on top of it. All images are available in high and low resolution. They are fully annotated in Coco, YOLO, TensorFlow, and some other formats, so being ready to be used for training the model. And they will be available under the Creative Commons Zero license, so you can build applications on top of it. Yeah, so I would wrap up here and will be happy to hear your questions.